Welcome to this explainer. Today, we're jumping right into the AI customization pivot, from fine-tuning to general models. Look, if you're trying to figure out how to best adapt large language models to your specific needs right now, you know the ground is just constantly shifting under our feet. We are literally watching a massive pivot happen in real time, moving away from traditional fine-tuning and shifting toward leveraging incredibly powerful general models. So let's just dive right in and unpack what's changing, why it's changing, and how you should be building your systems today.
So, the big question floating around the industry right now is this. Is fine-tuning large language models still needed today? To really get to the bottom of this, we kind of need to take a quick look back. It wasn't actually that long ago, we're talking 2023, when a well-known legal AI company decided to partner up with a major frontier lab. And their whole goal was to build a highly specialized custom AI specifically for lawyers. Because back then, the undisputed belief was that if an off-the-shelf general-purpose model wasn't quite hitting the mark for a niche use case, well, the obvious, and really the only answer, was to fine-tune it.
And honestly, at first, that assumption looked completely spot on. They ran these blind tests where attorneys were asked to compare their new custom legal model against the undisputed heavyweight champion at the time, which was GPT-4. The attorneys ended up preferring the fine-tuned custom model a staggering 97% of the time. I mean, 97%. It was an absolute landslide. They built a specialist that lawyers genuinely loved, and it made fine-tuning look like the absolute gold standard for enterprise AI.
Now, to really grasp why that custom model worked so incredibly well, let's quickly define what fine-tuning actually is. You start with a base model straight off the shelf. That base model has already been trained on a massive chunk of data scraped from the open internet, so it's got a ton of general knowledge baked right in. Fine-tuning is essentially the process of taking that base model and customizing it by literally continuing its training. But this time, instead of the whole internet, you feed it a highly focused data set. You can think of fine-tuning kind of like taking someone who just got a really broad, general undergraduate degree and sending them off to a highly specialized grad school. You feed it dense legal contracts, or maybe your company's private internal wikis, just to completely hone its expertise.
The actual mechanics of this process work in 3 distinct steps. Step 1, you grab that general base model. Step 2, you run the training with your focused, proprietary dataset. And Step 3, you get a brand new, fine-tuned model as the output. But here is the absolutely vital technical distinction you have to remember. In this new model, the actual internal weights, like the core mathematical connections of the AI itself, have been permanently adjusted by that new data. The result is a model that is inherently wired to be better at your specific, narrow tasks.
So that's the magic of fine-tuning, right? But let's fast forward a bit to 2025. That exact same legal AI company created a new benchmark to test their custom fine-tuned champion against the latest crop of general frontier AI models. And here is the dramatic twist. 7 completely general-purpose models actually surpassed their custom-built specialists. 7 of them. These were models that had never received a single drop of custom legal fine-tuning, and yet they were victorious. And, this wasn't just some isolated incident either. Bloomberg famously spent massive amounts of time and literally millions of dollars training a custom Bloomberg GPT for finance, only to find out just months later that off-the-shelf general models like GPT-4 were beating it on financial benchmarks. I mean, imagine having that expensive realization.
So why on earth did these general models catch up and leapfrog the super expensive custom ones? Well, it boils down to 3 main reasons. First up, massive context windows. Look, the original GPT-3 held about 2,000 tokens of input. Today's frontier models, they routinely handle 1 million tokens or more. To put that into perspective, that's like dropping the entire Harry Potter book series directly into a single prompt. If you can just hand the model 500 pages of legal documents right on the spot, why would you bother permanently baking them into the model's brain? Second, we have reasoning models. These newer models do extended thinking step by step at inference time, which is the moment you actually ask the question, rather than relying solely on how they were trained months earlier. And third, cheaper and smarter inference. The frontier models are just getting better so incredibly fast that custom training has basically become a moving target. By the time you finally finish shipping your expensive fine-tuned model, the next general release has already beaten it.
But this rapid advancement presents a really fascinating challenge for us. If we are no longer going in and permanently rewiring the mathematical brain of the model through training, how do we actually make it behave like a specialist? Like, how do we make it act like a legal scholar or an expert coding assistant right on demand?
Well, the most prominent answer today is RAG, or Retrieval-Augmented Generation. Think of this kind of like giving the AI an open book test. Instead of undertaking this massive, expensive training run just so the model memorizes everything,
Your application simply waits for the user's question, and at that exact moment, it instantly retrieves the relevant files from your database and hands them to the model directly inside the prompt. It gives the AI the exact context it needs exactly when it needs it.
Which leads us to a completely new customization stack, one that impressively leaves the model's internal weights entirely untouched. It starts off with context engineering, where a prompt is no longer just a simple question, but a really carefully engineered bundle of instructions and formatting guidelines. Next, we layer in RAG to grab that proprietary knowledge on the fly. And finally, we give the model hands, basically by using agent skills. These are literally folders of procedural code. So instead of trying to teach a model how to write SQL queries through months and months of training, a SQL agent skill simply hands the model the tools to execute it on demand. Literally any general-purpose model can just pick up and use that skill.
Utilizing this new stack is just a massive advantage because, let's face it, fine-tuning is incredibly expensive. And I'm not just talking about the sky-high computing costs for the training run itself. There's a whole mountain of hidden overhead. You're paying teams to curate data, run rigorous evaluations, and fix these annoying regressions where the model accidentally forgets old facts it used to know. And worst of all, you have to constantly retrain your custom model just to make sure it doesn't get instantly outdated by the very next big release.
So given all of these really powerful, agile, and frankly, much cheaper alternatives like RAG and agent skills, you really have to ask the logical next question. Does anyone actually still genuinely need to bother with fine-tuning at all today? I mean, is the entire practice completely dead?
The short answer is yes, people do still fine-tune, but for a much narrower set of very specific reasons. And actually, when teams do fine-tune today, they almost never rewrite the whole model anymore. They use a modern, highly efficient technique called LoRA, which stands for low-rank adaptation. Instead of retraining the massive base model from the ground up, LoRA allows developers to train a tiny, lightweight adapter. It's almost like handing the AI a super specialized cheat sheet.
In a real production environment, it looks a bit like this. You take the massive, incredibly smart base model, and you keep all of its original weights completely locked away inside a vault. You just don't touch them. Then, you train just that small LoRA adapter, and you let it sit right on top of the base model. This allows development teams to fix really specific bottlenecks without dealing with the total nightmare of maintaining a massive custom model from scratch.
So when would you actually reach for this kind of fine-tuning today? Mostly, you'll see it in three specific scenarios. First, low latency. If you are building a real-time voice agent, it simply cannot pause and wait for a massive model to think. You need instant reflexes, so a small, fine-tuned model is absolutely perfect there. Second, we have distillation. This is kind of like an apprentice learning from a master. You use a massive, expensive model to generate high-quality reasoning, and then you use that output to fine-tune a cheaper, smaller model. And finally, reinforcement fine-tuning, or RFT. This is for when you have definitive, objective right answers, like in math or coding. The model tries out different answers, an automated grader scores them, and the model updates itself to repeat its successes.
To beautifully tie all of this together, if you are building an AI application right now, today, this right here is your modern decision framework. Step 1, always start with a powerful off-the-shelf base model. Step 2, layer on some really excellent prompt and context engineering. Step 3, if you need fresh data, add in RAG. Step 4, if you're missing procedural know-how, integrate agent skills. And Step 5, only ever resort to fine-tuning if a specific performance or latency bottleneck remains that the rest of this stack just cannot solve.
We've seen how rapidly general models are evolving. I mean, they're jumping from holding a few paragraphs of context to entire encyclopedias. And we've explored just how capable RAG and agent skills have actually become. So looking at your own projects, you have to ask yourself a pretty critical question. Are you forcing a traditional fine-tuning strategy into a world that has already moved on? Or is it finally time to adapt your architecture to the new reality? Thanks so much for joining us on this explainer, and we will see you next time.
Thank you. Share and subscribe to Learn AI for more AI insights.